This is problem 1 on exam 2 of module 5 in the book Problem Solving Guide for Mechanics and Thermodynamics. 80 kilogram bag of cement is being used to test a bungee cord. The cord is 20 meters long, relaxed length, has a stiffness of 700 newtons every meter. The cement bag is released from rest from top of a bridge. It falls 20 meters before the cord comes taut because the relaxed length is 20 meters. What is the total distance the cement bag falls from the bridge before it's stopped by the cord? Part B, what is the speed of the bag after it has fallen a total distance of 22 meters and the cord is stretched 2 meters? Okay, we need a good diagram. So there's the 20 meters relaxed length. Here's the stretch, and it's stopped right here. We don't know what x is, but that's a variable. That's what we have to figure out. The total work done from the top, where it's at rest, to the bottom, where it's at rest, is 0. It ends up at rest instantaneously right here. It's going to be pulled back up, but it's at rest instantaneously. The total work done by the gravitational force on the bag of cement, we don't know how far it fell. It's going to be a function of x. The force is 800 newtons, the weight, and the distance it fell is 20 meters plus x. That's an unknown. The work done by the cord on the bag of cement, the cord only does work when it's being stretched. 1/2 kx squared, k is 700 newtons every meter, and x is the distance it was stretched. And if there's going to be no total work, the magnitudes of those two have to be equal. Sum has to be 0, one's negative, which means their magnitudes are equal. Man, this looks like a quadratic. We're going to have a linear term, a constant term, and a squared term. Maybe something good will happen. So let's just multiply it out. Divide by 50. We're just stalling here. Divide by 50, cancel the units of newtons to make it a little bit nicer. Looks like that now. I don't see how to factor it with that 7 there. Let's do a quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Got that memorized, don't you? You don't have to. So just plug it all in, grind away. We get 112 over 14 meters. That's 8. That's 8. And if it comes out nice, it means we could have factored it. We could have factored that thing. Let's try it again. There it is. Now here we know the answer is 8. So we can write x minus 8 meters as one of the terms. What's the other one? Well, to get 320 meters as the constant, that's the last. This term has to be 40. That's the only way to get 320. And then we have a 7x squared that we need, and here's an x. So this has to be 7x over meters. Okay, now let's see if it works. Let's get the cross terms. 7x over meters times minus 8 meters. The meters cancel. That's minus 56x. The inside is 40x. We have 40x on the inside, minus 56x on the outside. Ooh, that's 16x. Minus 16x. Minus 56 plus 40, minus 16. It worked. Dang. I was never very good at factoring. Let's check it. We know it fell 8 meters. The stretch is 8 meters. So gravity pulled on it for 28 meters. So gravity did plus 22,400 joules. The cord must have taken all this away, and it stretched 8 meters. 1/2 times 700 times 8. Ooh, minus 22,400. Exactly right. Que milagro. This is problem 1, and that was just part A. Yikes. On to part B. After falling 22 meters, the work done by gravity is the weight, 800 newtons times 22 meters, plus 17,600 joules. Gravity made a deposit of 17,600 joules into the kinetic energy of the cement bag. Now let's get the work done by the cord. It's negative. It stretched 2 meters. 1/2 kx squared gives us 1400 negative. So the total work done on the bag of cement on the 22 meters descent is plus 16,200 joules. That's the change in kinetic energy. The initial kinetic energy is 0. So that 16,200 joules must be the kinetic energy of the cement bag. And the mass is 80 kilograms. And we have to solve for V final. Multiply by 2, divide by 80 kilograms, take the square root, 20.1 meters per second after it fell 22 meters. I'm buying it. Sounds good to me.